chi-square goodness of fit test, okay? I'm going to use this example to demonstrate what is a chi-square goodness of test procedure and how can we actually what? Through the example to show you the details, okay? Example, the approximate percentages for the different blood types among white Americans are given below, okay? Blood type A, about 40%. Blood type B, 11%. Blood type AB, 4%. Blood type O, 45%. And we know human being can have only what? These four what? Blood types, A, B, AB, and O. So those percentage should add up to 100%. Let's check. 40% plus 11%, that's 51%. Plus 4%, 55%. Plus 45%, 100%. Okay? Next, a random sample of 100 Black Americans yielded the following blood type data. Okay? Randomly select 1,000 Black Americans. Okay? And we find 270 are of what? Blood type A. 200 are of blood type B. 40 are of blood type AB. And 490 are of what? Blood type O. Okay? The question asked, does this sample provide evidence that the distribution of blood types among Black Americans differ from that of the white Americans? Or could the sample values simply be due to what? Sampling variation, okay? Okay, let's use hypothesis testing. First step, let's define PA, PB, PAB, PO. PA is the proportion of Black Americans with blood type what? A, okay? PB similarly defined, PAB, PO similarly defined, okay? And those numbers 0.4, 0.11, 0.04, and 0.45. These are what? The percentage for white Americans. And PAB, PA, PO, this is defined based on Black Americans, okay? And we just wonder, the proportion consistent to what? To that of the white Americans, okay? So this is H naught, yeah? The sample consistent with what? White Americans what? Percentage of the blood types. And HA, say H naught is not true, okay? HA always H naught is not true. When you say this is not true, that means at least one of these proportions is what? Is not correct, okay? At least one is not correct. Okay, step 2. We choose alpha equal to 5% as usual. And step 3, test statistic use. We're going to use chi-square with what? K minus 1 degree of freedom. In this case, we have 4 different categories. Blood type A, blood type B, blood type AB, blood type O. 1, 2, 3, 4. 4 different categories. K equal to what? K equal to 4, okay? So in this case, the degree of freedom is 4 minus 1. That is 3, okay? So this is chi-square is 3 degree of freedom in our example. And our decision is we're going to reject H naught if p-value is less than alpha equal to 5%, okay? This is our standard procedure. Now, step 4. Calculations. Okay. 4 different categories. Blood type A, blood type B, blood type AB, and blood type O. Okay. And what we observe is what? What we observe is Okay, step 4, calculation. There are 4 categories. K equal to 4. Okay, 4 categories. And FO, from the random sample, we find 270 of blood type A, 200 of blood type B, 40 of blood type AB, 490 of what? Blood type O. These are what we observe in what? Random sample, our observation on the random sample of black people, okay? 1,000 black people. And FE is under H92, okay? The expected frequencies. Okay, now we have 1,000 people, black people. And under H92, the proportion of what? Black people in the sample consistent with white people's what? Blood type percentage. So if we have 1,000 black people, if black and white, the percentage of blood type are the same. So for blood type A people, 40% should of what? Blood type A. So this is times what? Times 40%. And this number should be 400, okay? This should be 400. Now, how about blood type B? 1,000 black people in the sample. And blood type people is what? Consistent with white people. White people's percentage is 11%. So this will be 110. And blood type AB, expected frequency, this is 40, okay? And blood type O, this is 450, okay? This is what we observe. This is what we expect when Einstein is true, okay? And then we need to calculate the rest. Okay, after we calculate this, okay? The detailed calculation is like this. FO, 270. Subtract by FE, 400. And the whole thing is squared and then divided by what? FE is 400. If you don't make calculation mistake, this number gives what? 22.25. Follow the same procedure. The next number, 73.64. The next one is 0. The next one is 3.56. So you sum it up, okay? Sum this number up, okay? Summing over what? FO minus FE squared divided by FE, okay? You sum them up, 42.25 plus 73.64 plus 0 plus 3.56. This number add up to what? This number add up to 119.4419, okay? 119.4419, okay? This is calculated what? This is the calculated p-value, okay? This is the calculated p-value. 119.4419, okay? In order to find the p-value, okay? In order to find the p-value, this is observer number, 119.4419, okay? 119.4419. and even what? More extreme. So this is a red shady area. The red shady area is a p-value, probability chi-square 3 degree of freedom, greater or equal to what? 119.4419, okay? This is a p-value. And to determine the size of the p-value, we need to use chi-square table, okay? This is a chi-square table. Major percentage based on the upper tail, okay? Now, degree of freedom, we have 4 categories. Broad type A, B, AB, and broad type O. Category is 4. Subtract 1 is 3, so degree of freedom is 3. Then you move along what? The row. You find those numbers. They are way smaller than what? Our calculated number, 119. The last one in the table of degree of freedom equals 3 is 17.73, and the corresponding upper tail is 0.0005, okay? That is to say, this is 0.0005, or you say this is what? Huh? Or you say this is 0.05%, okay? And the p-value is this one, is even smaller than the blue shady area. Blue shady area is 0.05%, and our p-value is even less than that, okay? Even less than what? 0.05%. So p-value is definitely what? Smaller than R5 to 5%, okay? So p-value is less than R5 to 5%. So we're going to what? We're going to reject H naught. Okay? Reject H naught, it means we're not going to believe this is true. Okay? We don't think black people's what? Broad type distribution is the same as what? White people, white Americans. Okay? So this is a detailed calculation procedure, okay? Of showing you how to find p-value.